Hello, this is Phil Thomas, New Era Systems. Continuing our testing of satellite amplifiers, today I'm looking at a CPI 200 watt C-Band. CPI, of course, is the item on the bottom. Normally when I test these things, I have a frequency generator. I plug it into the frequency generator. It's an easy one step. Most people don't have frequency generators, but they have a modem and they have an up converter. Well, they have an up converter if it's a TWT or an SSPA. This, of course, is a TWT. Let's just look at some of the components in more detail. This up converter comes from a bygone age. It must be 20 years old. I pulled it out of a stack of equipment that we just received for testing, and it works perfectly. In fact, it works quite a bit better than another up converter in that same stack, a much more modern one. The item on the top is modem. It's really just a modulator in this particular case, because these can be configured separately as modulator only or modulator and demodulator. This only has the modulator cards in it. I'm using it to generate 70 megahertz, and the 70 megahertz is going into this converter, and it's being converted to 5945 megahertz, which is in the low range of C-band. On the back of the amplifier we have a standard cross-guide coupler dummy load, and that's connected to two different devices. It's connected to a spectrum analyzer so that I can verify that the output frequency is correct, because amplifiers are normally resilient. They really don't care too much about the frequency output as long as it's generally within their range. But because I'm using an up converter, I wanted to make sure that the up converter is doing its job and is putting it out at the correct frequency of 5945. Just below the spectrum analyzer you can see the Agilent power meter. The power meter is set to watts today. Most often when we test we do it in dBm. In this particular case I've set it to watts. I've set the output on the front of the amplifier also to watts, and I'm going to compare the two as I go very quickly up the power range. There will be a difference because we're measuring the output on the flange, and that's going directly into our power meter. The output on the front is being measured somewhere within the CPI amplifier, and it will be a little bit more optimistic than what we're actually going to see coming out of the back. Okay, now let's see where we are. I tested this yesterday. I've got a cheat sheet here that shows that I'm going to be able to run it up to 232 watts at the low end of the frequency range and up to 214 watts at the high end of the frequency range. When I say run it up to, that's taking it up to saturation. It will go higher, but once you get past saturation, the increased power is not usable. So we only measure it up to saturation. And this is a 200 watt amplifier, and at saturation it's 232 watts. Another thing of interest in here is the helix current, because of course the helix current shows the health of the tube, and at no power it's 7 milliamps. At maximum power it's 2.7 milliamps. That is an outstanding value for a TWT. Let's do some work now with the modem. I'm just going to adjust the power level. It's negative 35 at the moment, so I'm going to bring it up to a couple of steps. We're going up to 49 watts. We jumped up to 118 watts. Now we're at 166 watts. We're still below the maximum output of this. Let's just look at the helix current out of curiosity. Oh, this shows that it's an attenuation has been set in the amplifier at 5 dB. and reflected power is 1 watt. That's kind of interesting. I'm not sure why there should be reflected power unless I haven't set that cross-guide coupler and dummy load on correctly. Okay, here's the helix current at 1.8 compared with what we saw a couple of days ago, 1.5, 1.7 in this range, so it's about right. Now we're going to go back to the output. That's in dBm. Output in watts, 166. I'm going to bring it up some more. Notice that as I press the increase, this value goes down. That value goes down because it's an attenuation. It's not really a power level. 224, which is just about right. Another reason I'm not going to bring it up much more is that dummy load on the back is only rated for 200 watts. So if I keep it running for quite some time, I'm going to be burning into it. 224 watts. Again, just verify that helix current, 2.6 milliamps. Excellent. This is where it should be. Normally ranges between 8.6, 8.8, depending on the amplifier. But it's normally somewhere in that range. And this is kilovolts, so it's 8,000 volts, not 8.6 volts. Okay, I think that's about all. I'm just going to bring it down now. Just taking it down to its lowest level. And even at the lowest level with this particular modem, it's still putting out enough juice to drive the amplifier at 18 watts. If you needed to drive it lower than that, don't forget, there is an attenuation in the amplifier itself. So you could set that from, I think it's set to 5 now, and you could bring it up to perhaps 10, and that would reduce this output quite considerably. So it would give you more flexibility at a very low wattage output. But of course, as a 200 watt amplifier, I don't know why you'd ever want to use it at much lower than 18 watts anyway. I mean, typically you would run these at 50, 60 watts or maybe higher. One more thing, just before I turn everything off, let's take a look at the amplifier itself. It came in with a consignment that was very poorly packed. That handle is damaged and scraped. There are more scrapes on that, down by this monitor port, and the top of it is generally scuffed. In spite of all of this unpleasantness, the thing still works beautifully, and it will be an excellent purchase for anyone who needs a 200 watt C-Band amplifier, probably last them for years. Okay, thanks for watching. It's Phil Thomas, finished for today.